Well, hello folks, and welcome to episode 257 of Retropower Uncut. And we're here in an incredibly quiet fabrication shop because everybody's gone for lunch and the booth has just stopped its bake cycle. We've just hung on for a few minutes so we can actually hear. It makes my life a bit easier not having to talk over that, although I do have quite a bellowing voice. It's easier not to have to bellow too much. Right, we're going to start with E-Type as per commonly and usual at the moment. And we've been wrapping up a few jobs that have been holding on for a while. We are still awaiting the rear hubs for this. We have ups and downs when it comes to these sort of things, but we are still awaiting those. However, you may recall from previous episodes that I made a mock-up hub. I made a mock-up hub using a standard Jaguar X300 rear hub and a Mark II Jaguar wire wheel hub, and combined the two to the correct dimensions. So although it doesn't have the brake disc fitment on it, it does mean that we can put a wheel on and it will be in the correct position in terms of offset. And we've been wanting to do that for quite a while. We were hoping to do it with the actual hubs. However, without going into lots of detail, that's taken an enormously long time. So we're using the mock-up hub, and that enables us to do that trial. And to do that, we've had to build up one of these outboard brake rear uprights with that hub. So I'll go into a little bit of detail on that. I think I've probably touched on it in the past, but I'm going to touch on it again now, just for those that are not familiar. Jaguar themselves, on the very late XJSs, stopped using inboard brakes and went to outboard brake, principally to get better brake cooling. Obviously, I'm aware of the engineering ramifications of moving weight outboard. I've been told about this by many of our viewers. However, more important than the issues with unsprung weight are being able to stop. And the problem with running the inboard brakes is getting cooling to them. That is a major problem, and the inboard brakes overheat on the higher performance Jaguars, and it is a repeated problem. It is why Jaguar themselves moved the brakes outboard on the later XJS cars, and why they then stuck with outboard brakes thereafter. So the facelift XJSs had outboard brakes. So on a wider car like the XJC that we're building next door, it's very simple. You simply transplant the whole Jaguar subassembly into the back of the car, very straightforward. You can't do that on an E-Type because the width of the subassembly, the subframe, is narrower, and there's a different length of drive shaft, so it isn't a simple bolt-in affair. However, it is doable with various tweaks, and those familiar with Jaguar stuff will probably be familiar with the process. However, I'll just quickly go over it for those that aren't. So, to avoid modifying and making significantly non-Jaguar parts, we managed to do it mostly with Jaguar parts bin stuff. So we use a standard E-Type rear drive shaft, which, as those who are unfamiliar with Jaguar stuff, that is the upper suspension link as well. So we use the standard E-Type drive shaft and upper suspension link. We use the standard E-Type lower rear arm. We then use a principally standard X300/XJ40 rear upright assembly, brake backplate, handbrake assembly, bearing assembly, and crucially the outer drive yoke that goes through that assembly, which is what bolts the hub into the other side of the assembly. The thread on the drive yoke is what clamps this. There's a nut down inside here that clamps all that together. So we use that drive yoke, and we could use a standard X300 rear bolted wheel hub assembly, but we want Y wheels on this car, hence making the hubs. Now I'm aware that we could make bolt-on hubs. I didn't want a bolted junction there for a very specific reason, which is why we're having the hubs made. My job yesterday, and Scott as well, was building up this assembly, and to do that we have to fit the X300 drive yoke to the E-Type drive shaft. And to be able to do that, there's a slight twist in the tail in that the UJ width is different on the E-Type drive shaft. The early type XJ setup or Jaguar independent rear setup uses a wider drive yoke than the later type XJ40, X300 setup. The drive yokes are different widths. But it's possible to buy, and I haven't got my prop handy, I've put it away over the other side of the workshop, an offset drive spider or universal joint for those two different yoke widths. So you can actually make the two fit together. You use a wider, you can buy a Spider with a drive yoke that is wider one side than the other to enable the wider width drive shaft to fit the narrower width drive yoke on the end and enable that mixture to happen. I was enlightened to this a few years back by John, who used to run Dave Mac prop shafts. He enlightened me to that information, and that's made life a lot easier, and we've done this in a couple of applications now. So that enables us to fairly easily fit the E-Type drive shaft to the X300 upright and get outboard brakes, leaving only one other problem, which is that on the XJ40 and X300 Jaguars, the lower rear arm pivot, this outer pivot here, it sits in a pair of taper roller bearings, very similar to what the earlier rear arm setups did, except that on the early arm they use a 5/8 pin straight through and then shims to preload the bearings and all the rest of all that caper. On the later setup, they use a tube to simplify that job, and there's basically a tube, and the taper roller bearings slide on the tube and are then shimmed for the preload, and they slide along the tube, and that keeps the alignment. And then they have an M14 bolt through the middle of that tube, which is also a camber adjuster, a toe adjuster even. It actually twists the assembly slightly and adjusts the toe. I think that's right. I'm pretty sure it's toe rather than camber. But anyway, they have an adjustable bolt on that. Now, we don't need the adjuster here. We'll adjust it using the shims on the drive shaft, same as the early type setup. But we do need to then be able to fit that to this arm. Now, the arm has 5/8, the lower arm has 5/8 diameter holes in the fork on the end of the arm and a 5/8 bolt through them. We only have a 14mm hole through the middle of the adjuster sleeve. However, what experience has told me that we can actually drill and then ream out that adjuster sleeve to 5/8 bore. It gets quite thin, however it's not really taking any compressive load, so it doesn't actually matter. I've actually trialled this on an assembly on the bench to establish whether when you tighten up the fork it can crush that tube, and it can't, because the ends of the fork are so strong that you hit the bolt tightening torque without actually putting any compressive load onto that sleeve at all. So we've actually done a little mock-up assembly to trial that. So what we found is that you can drill and ream the bearing adjuster sleeve for those taper roller bearings in the X300 upright to take the series stroke E-Type, whatever, early type Jag IRS 5/8 pin through the bottom, and that all works. So long story short of all that lot is we now have an X300 outboard brake later type Jaguar IRS upright connected to an E-Type lower arm and an E-Type drive shaft, which gives us outboard brakes. The camber is set within the same shim pack that the E-Type had. We actually removed 3 shims to get the camber to dead vertical at ride height, so we're well within the normal shimming range that Jag would have on that, and that gets us exactly what we needed to be able to put the wire wheels on. So following that, we then made, you may remember rewinding a while, and we'll talk about Bobby in a minute, but you may remember that Bobby designed an adjustable modular wheel to hold tyres on a car. It's actually fitted on the front on this at the moment, but Bobby made a modular adjustable wheel that could adjust from any size, I think, from 13 inch up to 24 inch or 22 inch. And any range, a ridiculous range of offsets beyond, either way beyond any offset that you would need, and also from various widths. I think it'll go from 5 inch up to about 11 inch wheel width as well. So it's basically adjustable to anything we would ever want to fit. But what it didn't do is have the ability to fit to a wire wheel centre. So I've made a new centre for that tool that I've then TIG brazed onto the Dayton wire wheel centre that we have, so that we can actually mock up and adjust the offset and trial a tyre on this car in the range of offsets that we've got and establish exactly what wheel offsets we want, because we can't adjust them with wire wheels. Once they're done, they're done. So we wanted to be able to adjust them and get the exactly the right offset range for the front and rear wheels. The wheels will be staggered on this car. We're running a wider wheel on the back than the front, remembering that it's going to have a circa 500 horsepower V12 in it. We do need to make sure that we've got some traction at the back, so we're running a wider wheel at the back than the front. I believe we're going to end up running 8-inch rear wheels, 7-inch front wheels. And we've just been doing some measurements and some checking with the camber set, the car set level. Scott got this all set level this morning, and just putting the suspension right through its travel, right from full bump on the bump stops, right to full droop, lock to lock, in all positions, just checking that we've got wheel clearances and that everything adds up, which it does. So that's good news. Other work on this car is that Scott has been wrapping up a lot of very small loose ends, tidying up little bits, brackets, widgets, all sorts of little odds and ends that need tidying up, most of which I've now forgotten. But I know he's been working on the infinite detail of trying to get plumbing through. So I know he's fabricated a box in the boot now to allow us to get the fuel fittings to turn through 90 degrees where they come into the boot and not foul the rear subframe, because we were so tight in space. I think last week I mentioned about that tight space issue we had there. He's now got a fabricated piece to allow those fuel lines through. He's got he's about to have a look at the power steering lines, and we were just discussing how to run the power steering and transmission cooler lines down the outside of the chassis on the front, because we need to keep exhaust clearance and wheel clearance and keep them looking tidy. And I think we're going to make an aluminium like a punched and swaged aluminium tray that actually fastens onto the outside of the chassis at the front to get those lines through, and also then have a section that will act as a heat shield on the same tray just to get the lines near the exhaust. We've got to get the transmission cooler lines uncomfortably close to the exhaust, so we need to put a bit of heat shielding in there. So lots of excitement going on there. I've also got a little shout out that I'd like to say, helping me along the way with these Jaguar parts once again, and I can't explain how helpful they are as a business, well, Simply Performance. I know we've mentioned them lots of times on here. They really are so helpful, those guys. Ben at Simply Performance has helped us out once again, in that somehow amidst our parts chaos, this is not self-inflicted parts chaos, this has been inflicted by somebody who I'm not mentioning, we managed to not have a drive yoke to mock this up with. And I thought, I need a flipping X300 drive shaft, because I don't have a drive yoke here now. I don't actually need one ongoing because we've got other solutions in place, but at the moment I need a drive yoke to be able to do this mock-up. And I dropped a quick message to Ben at Simply Performance saying, you don't happen to have a set of X300 drive shafts just laying around, do you? They're not really worth a lot of money, these things. It's just that I don't have any now. They've all been used to send bits to various places, and I don't actually have any on the ground here in order to mock this up. And sure enough, the next day, in a cardboard box from Simply Performance, pair of X300 drive shafts, free of charge. So thank you very much, Ben at Simply Performance. Saved my bacon once again. Extremely helpful guy, really nice guy. And also, they'll come back into this video again shortly when I hand over to Cal in a little bit, because we've also had another package this week for actually tail end of last week, so last Friday, so it just missed the video last week. Another package from Simply Performance of not free parts, but of final parts ready to go onto the XJC build, but I'll let Cal talk about those. But just a shout out again in great thanks to Simply Performance. Such a helpful business, absolutely a model of how to run a company. It's quick off the mark dealing with problems, quick off the mark with solutions, always got a solution to a problem. All the parts are nice, they don't keep rubbish, they generally have everything in stock, and if you need something Jaguar related, older Jaguar related, those guys will likely have it on the shelf. And don't waste your time trawling around for the parts, just email them first and then go looking if they don't have it. But just email them first. It'll be at the right price, the right quality, and they're likely to have it. So there you go. My little plug for Simply Performance for being jolly helpful chaps. And I think that wraps up where we're at on the E-Type. We're going to move on via the Saab, which will be my prompt to talk about Bobby. Bobby would like it known that he is absolutely overwhelmed with the response to last week's video. And he is a very, very happy man at seeing his fan club's response, which is significant, as you will notice in the comment section. So he's very grateful for that. So thank you very much indeed. I went to visit Bobby. Did I cover the fact I'd been to visit him on last week's video? I lose track now on the timeline slightly. No, I went to visit him on Friday, so it would have been just after the video last week. So I went to visit Bobby on Friday of last week, and he was in fine fettle, walking about in his ward, and doing very well. He just lost most of his extraneous plumbing, which he was very pleased about, because I think that was the peak of his discomfort, was the various means with which he was connected to various bits of monitoring and fluids in the hospital, but most of those had been disconnected. I think he still just had his wound drain in, which was taken out the following day. That was taken out on the Saturday, and he then messaged me on Saturday evening to say he'd been allowed home. He is about walking. I think he messaged me the other day to say he'd covered about 3 miles walking. He's taken his time, in Bobby terms, taking his time with these things, but 6 days after a pretty major operation, walking 3 miles is pretty good going. So yeah, Bobby's making good progress. There's still a mountain to climb. There's still lots to do, and you know, we don't run before we can walk, so to speak. But he's doing well. He's a tough guy. If anybody can do it, he can. So thank you for all your support. He thanks you for all your support. No doubt when he's back here, he'll do a little bit on video himself, I would say. But he certainly wants me to relay his thanks and appreciation for all your support. It's very much appreciated. And yeah, he's doing very, very well. I know he's back in hospital on Saturday, day after tomorrow, for a last bit of extraneous equipment removal. And then he will be back at home again then, and he's awaiting then the results of the biopsies and a plan for chemo, I believe, because he will, I would say with reasonable certainty, he sent me his the medical report on his operation, which meant that I then did a lot of Googling the other morning as I was getting ready to come to work on what all the various terminology meant. But I would say with my medical brain not really very clever on these things, that it basically means he's very likely to be having follow-up chemo, I would say. So obviously there's going to be a bit of a journey involved with that as well, and you'll be along for that journey, I've no doubt. Obviously Bobby, if Bobby's happy for that, then you'll be updated on all of that as well. But yes, I would say it's very likely that he'll be having a follow-up chemotherapy session to mop up after the operation, but actually everything looked good, and that the surgeons seemed very happy with how things had gone from his surgery. So yeah, that's where we're at on Bobby front. So I'm sure you'll be happy to be along for the journey, and we'll try and keep you all posted with how things are going. But he's basically in himself doing very, very well. Yeah, so fingers crossed for everything else, and thanks for your support. Moving on again, we have to skip past the BMW because we're a bit limited on people this week. Stu, bless him, has really quite well hurt his back. I suspect this dates back to moving his toolbox. He needed to, due to a change in various storage arrangements and things I'm not going to go into in the background, Stu's needed to move the other half of his toolbox, which was resident in a garage somewhere, to here. And being Stu, this toolbox is not lightweight, and even with it completely empty, it did weigh quite a lot. And Stu and I did a bit of carrying of it, and I have a sneaking suspicion this has not done his back any good. So Stu is not here at the moment. He is trying to sort his back out. He's back in for another bit of physio on it on Monday, and hopefully then he will have a functioning spine again. But this week he tried to come in yesterday and basically got here, was here for about half an hour, and then basically couldn't really move, so had to go home again. So he's not in a particularly good way at the minute, bless him. So hopefully a bit more physio will get him straightened out a bit. But yes, I suspect it was moving a behemoth of a toolbox, which has not done him any favours. So yes, slightly more limited progress on this week because Stu is broken. So we're going to move on to the Aston Martin, where there's been quite a lot of progress this week because Matt is not broken. Well, Matt actually was broken as well. Matt's actually had a load of tooth trouble as well, so we're all falling apart at the seams. We're all just getting old, I think. But yeah, Matt's had some tooth trouble, but he's kind of been working through that and grimacing a lot. But I think he's had his tooth more or less fixed now. So he's been working on the front end of this, and one of the key areas, once we'd kind of buttoned up pretty much everything we could as far forward as the engine, the next step step really was to be getting the front bodywork in place. And to that end, we've got to mount the front bodywork, and obviously it mounts at the scuttle and at the A-post, and then it will mount to an inner wing and splash shield. But further forward than that, it mounts to the inner front panel, and I think I've mentioned this before. The inner front panel we bought as a new item from ASR in Interceptor, and it's a very nice piece. Now that's mounted. Now one of the complicating factors was that the outer bodywork is rather bent on this corner, so we couldn't really use that as a precision piece of alignment. So with a bit of toing and froing, Matt and I had a bit of a discussion on a plan of attack. So he got that inner front panel loosely clamped in place in the front here, and we discovered that the damage along the front edge of this original front panel was such that we couldn't really get it in the right place. So Matt's ground off the very front edge of this, chopped that out of the way so we could get the front panel into the correct position. So we got that in, then we did some measurement based on the original front end, which we've kept behind the scenes. The original front end that was chopped off this Aston is in storage. So we've had a measure of that. Then we've used the original scan data from the good side of the front of the car where there wasn't the accident damage, and we've then mirrored that and basically got some key measurements from the scan data, compared them to our initial stab at the alignment of that front panel on the car, and actually they compared very, very well. So we then fabricated, or Matt fabricated, I drew up some little discs which have a centre locator that locates in the centre of the inner headlamp recess, and then a larger disc welded to it that sits onto here, that then bolts through the headlamp bolt pattern, and then that's centred by virtue of having a square hole designed to exactly fit onto 40mm box section, which you can see here. So that exactly centres that headlamp aperture to that box section. So we then, very simply, without having to tape measure and guess and compute, we know that basically if the bottom faces of those two boxes are level and those two are square, then those headlamps are in exactly the same places. So we welded those in, then Matt's made two uprights, exactly the same height, braced them, welded them to these plates, and we've set them exactly on centre line, exactly at the correct height, exactly at the same place fore and aft, so that we know that that panel is level, square, and at the correct height, and at the correct position fore and aft. And we've then cross-checked, done a final cross-check of all that against the scan data in terms of the position of this front panel and the position of the headlamps, and we're happy. We're within around 2mm in all directions on that. At that point we're happy, because that'll be a lot more accurate than it was on an original Aston Martin. And then that's enabled us to fabricate, or I say us, Matt, to then fabricate the front chassis rail extensions, which we were going to do bolt on, but we had a change of tack and then now no longer bolt on. They're actually welded on now. But we're doing the front chassis extensions out along to pick up that front panel, which Matt's getting on with fabricating now, and I think he's done both of those. There's a slight inward kick on those, but they basically continue the chassis rail dead level, and that happens to line up perfectly with the underside of basically where that front panel should be mounted, on the underside of the headlamp panel area, on the outside on the outside edge of the radiator, the original radiator support panel, if you like, on that front panel. That won't be supporting the radiator on this. The radiator will be mounted further back, and really that's the next step now on this, is to make the radiator mounting brackets which will hang off those chassis rails and hang the cooler pack, which is I'm trying to remember whether it was Corvette or Camaro. I can't remember now. Cal will remind me, but he's not here. I think it's a Chevy Camaro. Basically the Camaro or Corvette that would have originally had this engine. I think it's the Camaro cooler pack. So the aircon radiator and main coolant radiator are from an application that had the same engine at the same power level. So we kind of know that that cooler pack is good for this setup. And that's going to be mounted off the inside of the rails in such a position that we can feed that with a nice air duct back from the nose, and we're going to mount that slightly further back so that the panelling that enables the air feed to that will be able to have an aperture in it that can also divert some of the high pressure air from the front side of the radiator before it gets heated into the air filter housing, which will be mounted in the front of the car off on the outside of the chassis rail. On one side we're going to have the air filter housing, on the other side we're going to have the battery in the front. The weight of the engine is so far back that adding that bit of weight in the front is of no real consequence, and it keeps the boot area as clear as it can be for luggage, right, we often put the battery in the boot, trying to get weight further back. In this car, weight further back is not going to be a problem. The balance is going to be very, very good already. So actually we're going to have the battery in the front on this, simplify the wiring a little bit, use up some of this spare space in the front because we've got lots of spare space in the front, and also keep the boot as clear as possible, because by the time it's got the fuel tank in there, the luggage space is going to be diminishing. Still reasonable, but diminishing, and it's a GT car. It needs some luggage space, so that's the best use of the space. Matt's then also made up these oval tubes which are which are basically the perimeter frame for the engine bay, and the outer wings are going to be, he's got them screwed onto those, but they will finally be riveted onto those tubes. Those are some oval section seamless tube, which is shaped to follow the correct shape for the wings. He's actually shaped them to that side and then basically mirrored them, because this wing wasn't ideal, it wasn't quite right shape in the middle, and he's then done some panel beating work to get that to the right shape. Those are now in place. They're going to be gusseted into the bulkhead at the back, and welded into the front panel, the new ASR front panel at the front. And then we can start the fabrication of the further structure that joins the front panel into the chassis rails and forms the structure to which will fit the inner wing stroke, more actually just a splash shield, just a dirt shield really of an inner wing on this car. And we can actually get on to fabricating that. So I think that pretty much wraps up where we're at on the Aston Martin. There's been a bit of toing and froing in terms of the lower steering column. We've got a lower steering column in place. I think I mentioned that before. We've been doing the final spec for the universal joints on that, the splines, because we're running a Subaru Impreza steering rack on this, which has a 17mm 36 spline joint onto the rack. The steering column is Jaguar X300, which is 17mm 54 spline, and we need to get from one of those to the other via two universal joints, one of which needs to incorporate what you'd call a rag joint, or basically a rubber, to take some of the harshness and vibration out of the steering, because the steering rack is it's not solid mounted, it is bush, but it's quite solidly mounted. This isn't really a full-on sports car, it's more a GT car. We want to keep a bit of MD8 out of the steering system, so we're going to put a rag joint in that steering column as well. So all the ducts are getting in a row that in terms of parts, so we've just got to put the final pieces into place, but we've got a temporary column in place at the moment which will enable us to steer the car should we get to that stage before we've actually got the final column fabricated, because the joints have got to come from the USA. I seem to have lost, here's one for our viewers. If any of you know of a universal joint manufacturer supplying the automotive market in the UK, please let me know. Because over the years we've dealt with Nakam in Wales. They've now gone, which is sad. They used to supply Toyota and Nissan among others. They've now gone. We then dealt with B Squared Automotive in Coventry. They've now gone. They've gone into liquidation. We've dealt with RL Walsh in Coventry, who were also Evolution Automotive Components. They've now gone. And we now deal with Kylie Clinton Engineering, but as far as I'm aware, all of the universal joints are now imported. So if anybody knows of a universal joint manufacturer in the UK, please let me know, because I don't actually know of any anymore that deal with the 15mm type steering column universal joints, the ones that use the 15mm bearings. I don't know of anybody making them in the UK anymore, which is a bit of a sad state of affairs. Anyway, moving on from that, I'm going to gesticulate from here. There's not much point me swinging around there. In terms of the body shop, you saw the Alpha Sud last week, I think. You've certainly seen it on the Den videos. The Alpha Sud came in for some paint. Gaz has just finished off the paint work on that. A few little nitpicks, got a couple of little bits of corrosion on the wing and on the windscreen surround, so some very careful windscreen removal, because we don't know if the glass is something we can actually get hold of or not. It certainly won't be easy to get hold of, so that was a bit of Gaz's very careful windscreen removal, which he's done, got that done, and got the paintwork sorted. A bit of very careful trim removal as well, because again we don't know how replaceable the trims are, probably not very. Got all that sorted, got the paintwork done, got a paint match sorted, got that lot done. He's just literally putting the wheel back on that and getting the final bits put back together on that now. And then that's just in time because Gaz is actually off next week on his Scotland trip. So he's off on his annual Scotland trip next week, so that kind of ties in quite well. I think then there's actually quite a stack up of paintwork likely to be coming in from the den, looking at the jobs around in the den. And then I think he'll pretty much be in line to be getting on to the Jag V12 E-Type. That's actually looking pretty close to paint prep now, so that's where things are falling into place on that. And I think on that note, it's probably time to hand over to assembly shop and see how things are going in there. So see you in a week's time.
Bloody hell, he's pressed record and I'm still drinking my Roundstone coffee. Right, I'm going to start with thanking Nat actually for his segment of the video. Thank you very much, Nat. I'm going to start, follow that with a thank you for this amazing card. Nat had already thanked for all of the amazing supportive comments that we received for Bobby, but this was probably the icing on the cake from Marcus in Weston-super-Mare. This incredible Photoshop, which is slightly alarming, and it appears to be George's hair and moustache on Bobby's face, or at least, or maybe Bobby's eyes and nose photoshopped onto George. I'm not quite sure, but it says, after spending too much time in the CAD cave, Bobby was delighted to get back in the workshop. Absolutely brilliant. Had us all in stitches, that did. So thank you very much. I'm going to move on from that to this, which is the rear section of a whole batch of grills we have designed and had made for the Quattro that is down in the den. So basically it had originally some mesh grills in various places on it, and one of the things we were doing on that was doing a more OEM looking interpretation of all the grills. So we've done grills in all the bumper at the front and in the back, which kind of replicate the original Sport Quattro front grille. And then where the number plate would originally go, because we've got a radiator in the back in that car and the air outlet from that radiator is basically through the original number plate area, we wanted to just make that look a little bit tidier. And originally there's a section each side which kind of has this rib design on it. So we thought, well, we'll carry that on and basically create a centre section that looks like it should have always been there. And that leads me on to a subcontractor we're using. Now, long-term viewers will know we're not overly keen on using subcontractors for work, generally because we're disappointed with the quality of the work. But we do have a few go-tos, and for machining work, Jonathan at PBE CNC and Andy at Concept 303 have been now for a long-term subbies of ours who are always absolutely crack on in terms of communication, quality, timescale, price. They're always the things we're looking for, and the key ones being the quality and the communication, just keeping us up to date with where they are and making sure the quality of the work is almost impossible to top. And for a long while we struggled to find a subcontract 3D print company. We do quite a lot of 3D printing in-house. We do a lot of interior parts in carbon reinforced nylon. However, we're restricted in the build area in our machine to about, I think it's 350 by 350 by 350 in the new machine. And if we're making parts that are to be an exterior part where their surface finish is going to be the final visible finish, our machines aren't really up to the job. FDM printing basically isn't the right approach. That's the type of printing where there's a filament being extruded and basically building up layers. And it doesn't really give a good enough finish for that. So in those instances, we need to use a different method called SLS printing. Or if there's a bigger part like this, which won't fit in our machine. And after much anguish using various companies that let us down in every respect, we came across Prototal, or as the Scandinavian origin would probably pronounce, Prototal. So what I wanted to do was go to Prototal and show you what they're all about, which is what we're going to do now. Welcome to Prototal, and you can tell a lot about a company by the cars in the car park, and these days the strangest cars attract our attention, so immediately we clocked the short wheelbase Shogun over there, which is way cooler than it has any right to be. Of course the Supra. Jamie immediately clocked the Seat Leon of all things. We don't know how Jamie's mind works either. This, don't know about that. I mean, who puts a Defender private plate on a Defender? Come on, man, you can do better. Let's go inside and meet the guys. Okay, we're in Prototal HQ, and I'm here with Connor McAleer, who's been our extremely good representative over the last few months.
Thank you very much.
Hello, Connor.
Yeah, it's very kind of you to say.
I wanted to give you a show round because I think when we talk about subcontracting 3D printing out to companies, you sort of imagine it's a little tin pot office with a couple of printers shoved in the corner at best, and basically a man receiving the files and then pressing a button on the printer and out pops the thing, and all they do is pop it in the post and watch the money roll in. And it's a little bit more advanced than that, and I want to sort of demonstrate why there are situations where we need to subcontract our printing out. And I think one of the first things I want to talk about is the different printing methods that there are and the situations that they're used in. So Connor, if you could talk us through what you've got in front of you here, that would be wonderful.
Yeah, of course. So 3D printing is it's quite a general term, and we've probably done it to ourselves in terms of marketability of it, because everybody lumps all the technologies of 3D printing under one umbrella, when each technology can have a different use case, different applications. All of them do well in certain aspects, but don't do so well in others. So we've got a wide spectrum here, and we try and reduce the noise for people when they get in touch with us, because initially you might say it needs 3D printing, but then trying to identify the correct 3D printing method is kind of where we come in. So it wouldn't just be a matter of receive your file and like, oh, we printed it, and you get it through the post. Like you said, you're like, I wish I knew that this isn't the right method. I wish I knew that there's a different way of doing it. But one of the methods that the original one in 1989, the stereolithography, or SLA as most people will know, because nobody's going to say it the full name because that's way too long. But this really gives you an incredible surface finish with it. So if you've got parts that need to be in sight of customers, visual components, but they need that preciseness as well with the resolution, then you can have a really good go with SLA.
It's absolutely amazing.
But one of the things with SLA, similar to what I was saying before, is that they have the benefits and drawbacks, is that maybe for parts that need a little bit more structural integrity, parts that go into a little bit more stress, you might need certain materials to be able to identify, but maybe that isn't the right method for it. So it's great for visual parts, great for prototyping, demonstration pieces, maybe non-structural kind of side of it. But then the one that probably everybody's familiar with, if you know 3D printing and they have their own at home, we were just talking about different processes and different elements, but FDM, or fused disposition modeling, or as FDM as everybody's going to call it, because they're not going to say the full name again. But this allows you to be able to print in a massive plethora of different materials, wide spectrum, because you guys have got FDM right at house. So with the early stage prototypes, visual kind of elements as well, maybe that doesn't need the surface quality that SLA provides. FDM is brilliant for that, but also on FDM you can get some really high performing polymers that exceed temperatures of 200, so it could be the peaks, it could be carbon peaks, you've got ultims. This allows you to be able to get up to replacing metal kind of components. But similar to SLA, there might be some design considerations. If you've ever printed some at home, you know the 45-degree angles and those kind of things, but we'll always talk you through those elements. And then probably the one that's used more often for productionized 3D printing is SLS or MGF. So you have those two different sides of it. So it's powder-based printing, essentially. You get a high concentrated laser and you can etch out the part until you replace it, and we'll see probably better downstairs when you visualize it. But this component is used as a brake duct. So this is actually a productionized part. It's used by a niche vehicle manufacturer. I have to say it like that because I can't say the name. You'd
have to kill me.
I'd have to go. But these parts really allow you to be able to, so sometimes when you've not got the answer for those quantities between 1 to injection molding justification, these parts really work quite well for that kind of size. So the majority of our work is through powder-based. But depending on your application, we can talk through the different ones really.
I mean, this is probably what we've most commonly used you guys for, because we can get a surface finish which we feel is good enough for an exterior component on a car when it wants to look like plastic, basically. So that's amazing for that. And as you say, this we can do in our Bamboo Labs machines, but we're restricted on size, which is when we would hand that over to you. And then this, when we want something insanely good in terms of its surface finish. So perhaps like an interior component that's actually going to be the final on-show part in the car. So they all kind of have their place. I'm interested to see the machines that you're using for all of this, because they're a little bit more advanced than ours, so shall we go and have a look?
Yeah.
Cool. So, this is quite impressive. What type of machines are these?
So these are selective laser sintering machines. So the part that we showed, the brake ducts, they would be made on this machinery here. And as you might be able to see, they are pretty large outfits that we can print on. So the build volume that we've got max is about 700, 380, 580. But if there are parts that go slightly beyond that, I can work with Tom upstairs to be able to find out whether there's an opportunity to be able to do it at a different angle. But we'll always warn you about potential compromises that will have be able to do this different things. So full transparency from ordering it all the way to delivery. Prior to ordering it, we'll make sure that you know all the information you need to know.
So how do these machines actually work? Are they filled with powder somewhere?
Yes. So in here is kind of a case of powder. That actually gets inserted in here, but then you have a high concentrated laser that goes through the powder. So this is nylon 12, for example. You've got a machine in there that does carbon filled nylon as well, same build volume, same process, but a high concentrated laser etches out your part, which will be uploaded by Tom up there. And then once it's done that first layer, then it replaces the powder on top and keeps like going down until eventually you've got your part that comes out, and it's incredibly cool to be able to see the whole process. I do recommend, if you have time, to be able to just YouTube like selective laser sintering, and you can just see the whole process. That's it.
So does the powder come to you like literally ready to just put in these machines, or do you have to do something with it before that?
So we don't. So in terms of using the powder, so it's very rare we would ever use virgin powder unless it's specifically requested by a customer. Around the corner we have our mixing station, and it's quite impressive to be able to see. It's a huge drum, and you can see it mixing around, and you can almost mix it as many times as you want. There is a point where we believe that it might compromise it, but then that's when we use it as road paint, for example. So it does get used even after it's being used.
Shall we go and have a look at that?
Yeah.
Cool. So welcome to what looks like the narcotics department. These guys, I'm pretty sure, are loading these drums into a Cessna somewhere parked outside. What's actually going on here? What's in these drums? What are these for?
I can't legally say what it's actually used for, but but these gigantic drums here is what we've talked about before in terms of mixing the powder. Because when you get an opportunity to be able to mix it, we do it in quite a large drum. But one of the great things about working as a group, as a Prototal, I actually said it the Swedish way this time instead of the Northern way, but the entire group is the largest buyer of powder from EOS.
Wow.
So that means in terms of contingency plan for people who want to scale up production in terms of having just a few off, all the way up to hundreds, and then we go like, if we have any supply chain issues, they prioritize us to be able to do this. So this entire room, as you can see, with all these different drums around here, these different boxes, all different variants of the powder materials. So we've got flame retardant version of the powder here, the carbon filled, we've got the glass filled powder, and the powder that we use mostly for your parts is the standard nylon 12 components, because the majority of applications will work with that one. And we will let you know if we think we may be overkilling it by going to carbon filled. We could like, maybe, I think nylon 12 is going to satisfy that application.
Yeah, absolutely. I'm interested to see what the parts look like when they first come out of the machine and what's involved with cleaning them up a bit. So shall we go and have a look at that?
Yeah.
Right, so I'm guessing these are how parts come out of that machine?
Yes. So this is when it first comes out of the machine, but prior to this is the cooling stage of it. So around the corner, we do have some boxes that some of the machine, the parts go into, and we pump it with nitrogen to make sure it doesn't oxidize, decolor, or compromise kind of the mechanical properties of it. But once it's, say, about 20, 24 hours it's been there, or maybe even 35, depending on the size of the part, then it comes in here, and you can see all the excess powder on there. And when we're talking about the narcotics department, you can kind of tell why that's it. But this excess powder isn't useful for the customer, so ultimately it needs to be removed, but removed efficiently instead of damaging the part, going through, and then once it's had it all removed, it's a bit of a smaller version of it, but then you get this as the kind of the finalized part.
Yeah, it's amazingly crisp and defined, isn't it?
Yes. So you have this kind of element of it where we have different methods. So we've got the kind of the standard one that we use, which is an air blaster, which most companies are going to be able to use, but we've got like more automated machines around there to be able to, say, if it increases in the amount of volume of parts and lead times for integral, which every company wants their parts yesterday.
Yes, myself included.
So then they can go into those different machines around there, but depending on what you need, this could be the standard finish that you want.
Yeah.
But there is an opportunity to be able to like vapor smooth it, vibro polish, different finishes you can get.
And now, a lot of the parts we're getting are black, but they come out like this, presumably, and the black is applied afterwards.
Yes, yes.
So should we go and have a quick look in the solvent abuse room now? Right, so the parts, as they come out of the machine we've just seen down there, are very nice, but they have a slightly kind of textured finish to them. And I know a lot of the parts we've been getting from you are not only black, but also a very nice smooth finish, which we think's good enough for exterior parts on a car. How do you get from the textured to the smooth?
So there's a process called vapor smoothing. So with the AMT, we use the post-process, so it's a machine, it's kind of like an oven in a way, but it vaporizes the external crust, reducing the porosity and then making a really smooth surface finish that you can see there.
Awesome. And then when it's going to be black, in this case, how's that achieved?
So right next door in the workshop we've got dyeing station, and we've got like different variants of it, so we can do it in the pot dye, we've got a machine called Dimension where we can do the dye. It really depends on the application, but majority of parts go through the pot dye.
Okay.
Just through there.
You want to show me that?
Yeah.
Cool. Let's have a look. So I knew there was a place in here that didn't look absolutely immaculate, like you could eat dinner off it. And in the, just like our paint shop, which seems to accumulate spilt paint like you wouldn't believe, this is the dyeing area, I believe. So tell me a bit about this.
Yes. So this is our workshop for all the 3D printed parts that we showed before. Quite often, people maybe want some additional finishing to it, but that is something that we can do in-house, because quite often you get people who can supply you parts, but then there's still quite a lot of work that you need doing once you get the parts, and then it kind of defeats the object of subbing out, because then you have to do most of it in-house. So we have full dyeing, paint shop, we can do heated inserts, do welding as well for parts that maybe go beyond the build volume. There's plenty that we can do here, but it's just mainly driven by what your product needs. So if you say you need those kind of things, pretty sure we'll be able to do something in-house, or might be able to do it in group, really.
Cool. Is the dyeing, just out of interest, the dyeing, is that like by submerging the parts into the dye, or is it sprayed, or there's a different instances where
there's different instances. So with, like, say, a lot of our automotive companies need a specific route colour. For example, if it's not black, there we go, like where we can paint it and we use a spray in there. So we've got the workshop to be able to do that. And then dyeing, it is quite a process where it is dipping it in, and if it's a larger part, then we might need to double dip it to do it a different one.
Cool. And I'm guessing after all of this is complete, then you must have an area where you check the quality of things. Should we have a look at that? Yeah. Wonderful. Okay, well, last but not least, we've got our parts, they're printed, they're vapor smooth, they're dyed. You're ready to send them out, but I guess there's one last step. So
there is one last step with it, and the reason I'm holding this is not just to be different. This is a validation bar. So each build that we actually produce on the SLS has 6 of them in each layer of the deck. So 2 in the corner, 2 in the middle, 2 on the side, and every single one of these gets measured to find out whether it is to our tolerance. And beforehand we were measuring 10% of the whole build. Well, now we can measure this, and if any of these deviate outside, then we can check all the different builds. So at least we can have conformance to our tolerance in. If people do need specific tight tolerance in and things like that, we do have measuring equipment next door, but the majority of parts that we can push through are absolutely fine in terms of adhering to our tolerance.
Awesome. And are you ISO accredited in some fashion?
Yes. So we do work quite a lot with automotive companies like yourself, but aerospace we work with as well. So we have EN 9100 and medical, we have that for 13485 as well. So that's custom kind of surgical guide tools work by way. But for the aerospace one, in-flight components, we don't do the design, we can conform the manufacturing process. So we work with companies to be able to help on that side.
Awesome. Well, hopefully that's given you a reasonable insight into the fact that it isn't just a man in a room pressing a button on a machine that spits the parts out and they go straight in the post. And I've no doubt we'll be placing a lot more work with you over the coming months and years. So Connor, thank you very much for showing us.
Thank you very much. Thank you.
Okay, I hope you enjoyed that little tour of Prototal, and we're going to start here with the AJ16 supercharged engine that's going in Project Portofino. We showed you last week the block, and the head was just in the process of being built up. We've gone a little bit further with this now. We've got one of the cams in, and Adam's just in the process of measuring for the valve shims. So it's a solid follower engine, so the valve clearances are shimmed, and that means we go through the process of measuring up for the shim sizes. That will all have changed from original because the valve seats have been recut in it. So that is a case of getting the camshaft in there, moving it around until you get the widest clearance to the follower, feeler gauges to measure that gap, recording that and repeating it for every single one, and then using the factory valve clearance measurement, so that's the gap there needs to be between the follower and the cam lobe at its greatest point. You deduct one from the other to get the thickness of the shims that are required, and then what we will do is get all the valve shims ground to those thicknesses, obviously recording which valve position each of those shims goes into before they're then finally fitted, and then the cams can go in for the final time. So that's what we're on with on that at the moment. Let's go and have a look what's going on in the workshop, and we will ignore this elephant in the room and talk about this next week. Right, moving into the workshop, we'll start with Interceptor. So we had the transmission back last week. The guys have been building that up with some of the exterior parts ready to get that in place. So the brackets for the gearbox cross member, the unions for the cooler lines, and some other exterior components getting assembled onto that. And then last week I think we showed Steve laying out and modifying the engine harness for that engine because it's got a different auxiliary drive kit on it. Things are in a slightly different place, so we were rerouting some of the wiring for that. However, we also discovered that the connectors for the crank sensor and the cam sensor didn't fit their corresponding sensors, and they were basically the wrong way around. The connectors are almost the same, but there's a little keyway and it's in a different position on the crank one to the cam one, so you can't plug it into the wrong sensor. And they were basically the wrong way around, and we thought, well, they could have just put them on the wrong way around in the factory, but we better check. So we basically pinned everything out and made sure that the crank sensor connection on the ECU did go to the crank sensor wire, and the same for the cam sensor, which they did. So we basically concluded that the housings had just been put on the wrong connectors in the factory, which is slightly odd. I imagine it could happen, but you would think they'd have a test rig where they have to plug all the connectors in to test it, but who knows? Anyway, we've resolved that. Re-loom taped all the loom back up for that, so that's now on the engine. We're just making up some brackets to retain the rear part of the loom on the back of the block to keep it kind of up and above where the transmission goes. As soon as those brackets are on, transmission can go on, and I would say, with a bit of luck, that might be in the car next week. Couple of other bits and bobs on this. So the C-pillar vents, they have like a fiberglass duct that sits inside, which in true Jensen fashion is a bit of a cobble up and doesn't fit very well. So Toby has been sort of reshaping those, fettling them to get them to fit nicely, basically getting some brackets on them that retain them into place onto the inner structure. And then once all that's done, there's like a little metal bar that goes across on the outside that holds the Jensen badge, and then a bezel around it, which we've got to paint body coloured. So we're getting everything in place for the C-pillar vents. We're just starting to reassemble the window regulators on this. So we had the motors completely stripped and rebuilt and rewound. So we're just building those back up into the car. And then, yeah, I'm hoping the chrome's not going to be too long on this, because I was saying to the owner the other day, there's kind of a domino effect of big progress coming up. There's the engine and transmission in, then the chrome allows us to basically get all of the glass in, and then very shortly James is going to be looking at the interior on this. I was going through it with him the other day, just kind of discussing the various components involved. Some of it's already been done through a long and convoluted story, but Richard, our previous upholsterer, actually did a lot of the interior on this in a previous life, shall we say. So some, like the seats and the door cards, are already upholstered, but we've got to do basically everything else. So yeah, exciting times imminently ahead on this. I'm going to talk about Portofino. So we've obviously looked at the progress on the engine for that. Last week we saw an exciting looking box arrive over there, which was from Simply Performance, because they had finished building up the hubs and the diff, which is actually lurking on the trolley over there. So we subbed that job out, particularly the diff, because the setting up of the mesh between the crown wheel and pinion on that and setting the bearing preloads, etc., is something that, although we could do, it's a lot more efficient with somebody who's done it, time and time and time again, and they're just so experienced with building those. It makes sense to sub that out, because again, when there are reliable people we can sub stuff to, we're not shy of doing that if it's the most efficient way of doing the job and therefore is most cost effective for the customer. It's just very rare that we can trust people to have the same attention to detail that we would like to think we apply to everything. So, those subcontractors are relatively few and far between. But yes, diff is back. These are back. We're just doing the final build-up of various components on these, ready to get the rear subframe built up. And one thing we wanted to do before the subframe goes in is the fuel plumbing. So I think we'd showed in the boot the whole pump and sort of filter arrangement in there. So we've got a Holly lift pump pulling the fuel in, feeding to a I've forgotten the name of the high pressure thing. Basically, there's an anti-surge tank with a high pressure pump and the regulator built into it. It circulates within it. It circulates the bleed by from the pressure regulator back into the reservoir. So it only has a single line output. So we're running a dead end fuel rail on this with a single line, which is one of the things the guys have been doing this week. So we've got a combination of ATEC and racing lines parts. So that all the hard line, which is the whole run under the car there, is in ATEC hard line with the ATEC sort of threaded fittings on the end. And then the flexi sections are in a product called Superlight from our local supplier, Racing Lines, which is a really, really good fuel line product. We've tried and tested on so many cars we've built now. Very flexible, which is one of the great things. Lightweight, which is great on a racing car, not so relevant on this. It's just very nice to work with. So we've got a section of that over the subframe, which has got also heat protective wrap over the top of it, because it's not a million miles from where the exhaust routing will go. It's not right next to it, but it makes sense to have that there anyway. And we've got the same here actually. We probably showed this before, but these are the hard lines on our revised fuel setup on this. These pipes that join the tank. So this line running across here, which is also Racing Line Superlight, but I think it's probably -12 size, which has got the heat protective over it as well, because the exhaust will be coming over the top of that. That then tees through here to feed the fuel lift pump, so both tanks are linked together. And then this is the return here from the bleed on the reservoir back into the tank. Moving on from that, but staying on a plumbing theme, brake plumbing is the next thing we're looking at. So we've got the pedal box loosely in, so we can just mount up the original servo and master cylinder. They will be replaced with new, but there's no point mocking up with the new ones at the minute. So we've got those in so we can do the brake plumbing. So we've just been planning out the exact routing of the brake plumbing in the front there, where we're going to put the T-piece, so we can run the hard lines to the front. There'll then be a hard line also coming to the back on the opposite side to the fuel line, but running exactly the same way. Also ATEC pipe, just a smaller diameter version, which will run to the rear subframe, and then that will be teed to the rears via an AP bias valve, so we can restrict the pressure to the rear if we want to do that. So that's that, and there was something else, front subframe, glaringly obvious one. Over the last couple of weeks we showed the front subframe being built up. That is now in the car. I think the remaining bit on that is to get the calipers on that, so then that will also give us another component in so we can get the front brake flexes made up, which will also be in, they'll be in like a Teflon lined stainless braided material. So yeah, all kind of steady progress coming together, lots of progress on different fronts effectively. So that's where we're at with that. Lost my train of thought a bit now. Churchill is probably the other thing. So brake reservoir is now fitted on that. So that's a billet machine part that we've designed and made. It's actually very similar to the one we did for Project Utah. We just made a few subtle changes on it. So that's now fitted. Luke has been carrying on with all of the 3D surfacing of the perimeter trims that are going to go around the quilted headlining that James has done on that. So it's probably an opportune moment actually to hand over to Luke, and he can show you what he's been doing.
In the room. CAD Crypt. We're going with that. We've probably said it already. Hello, welcome back to the CAD Crypt. So this week I'm going to do something slightly different to what we normally do, which is, again, me and Luke have always been on, we're always on lots of little bits and bobs jobs, and I've been on a lot of bits and bob jobs, mainly with E-Type stuff as well. But I'm going to go specifically into something for once, which is cap design, which is incredibly exciting, and I'm sure everyone's going to really like it, but we'll see. Let me know, let us know in the comments if it's something you want to see more of us deep diving into specific parts. So with a lot of the tanks we do that are going to be completely custom, we try and have it so we can orient the caps. So for example, on this tank, we've got 3 caps. We're going to want them to all be a similar orientation. We've done different versions of this in the past, of how to make them so they always tighten up to the same point. The first versions had an O-ring on the bottom of them, but then as the O-ring kind of slackened and got softer over time, the cap would then tighten slightly more, slightly less, and then over time they become misaligned. So we kind of went away from that design. Then we moved to a design that we've used on the Escorts and the Allegros, which it puts the O-ring in the side of the cap and allows it to tighten up onto a solid plate, so it always tightens to the same spot. The problem with that is it kind of meant they had to be made exactly perfect first time, and if they weren't, then you had no way of adjusting them, really, because if you then sand a small amount off the bottom, it then turns out a huge amount, and it's just causing loads of issues. So this is the version 3 design, which is we are now 2 pieces. So the idea with this being, this is the same design as we've kind of had on the Allegros and the Escort, where you've got an O-ring in the side which does the actual sealing, and then to stop the caps going to make the caps to go to a defined height, they bottom out on the bottom, so they screw down and bottom out. But then to make it so we can adjust them if when they're being made they've been done slightly wrong. Well, it's not even wrong. It's just you can't determine where the threads are going to sit. We've done it so the top is now going to be a separate piece, which that's probably going to pop the hell out of the microphone. Which means we can now screw them on and get our orientation perfectly correct. That is all adjustable, and then we'll bond them on once we're 100% happy with the position of them. Meaning that on all future tanks and fuel caps or whatever, we can have it so the cap is always perfectly aligned. This one has been specifically challenging, should we say, because it's the cap for one of the caps for the tank. This is for the brake reservoir. We've tried to add a diaphragm inside of it. So this is what OEMs use in brake fluid reservoirs to stop moisture getting into your fluid, so making it last a lot longer. But making that all fit into this tiny little cap has been interesting, but we have managed to do it. It's been a few iterations and a couple of heads togethers, but yeah, we've made it all fit, so that's going to be a bit complicated to machine. I'll have a little bit of B-roll in the background for you so that you can kind of get an idea of it. But yeah, it's one of these. This is one of those kind of jobs where if you say how much time you spent into making a cap and designing a cap, you'd be like, have you spent that much time? But there's so much that goes into these things, and fettling them and testing them, making sure everything kind of works exactly how you want. Because at the end of the day, we're trying to make the best physical car possible and kind of be, as much as we can, industry leaders. So yes, it takes sometimes a lot of R&D into something which doesn't feel like it should have a lot of R&D. Yeah, I'm going to stop ranting about that. Let us know if you like this little deep dive onto this. I'm sure you probably do, because it's the kind of thing Nat normally does, but we're going to try and bring it up here potentially if you like it. But now I'm going to pass over to Luke, where he can talk about all the different things he's been on with. Thank you.
Hi guys, welcome back to my segment of the video. This week has been predominantly based around one thing, so I'm going to stick to that, and if anything, I'm probably going to be a bit too honest here. So the Churchill roof trims, people who watch every single week probably know that I was prototyping a version of that a few weeks back, and the bits that I was prototyping fitted well. They followed the line of the car. You could bolt them to the car, and they were really good. But one thing that I was noticing, and one of my biggest downfalls as a designer, really, is that when I came into this job and designing in general, I had very little experience, and I was doing a lot of part design stuff which didn't require a lot of organic surfacing, so kind of like the shapes you can't achieve using blocks, chamfers and fillets and everything like that. And Cal's mentioned it before that with some of my interior design stuff in the past, it just needed to be a little bit more organic, and I did that, and I practiced that, and we got to the result that we needed, but sometimes not necessarily in the best way. And I was finding with these roof trims, I was getting to the point where I was trying to trace out the line and then extrude it through that surface, bring it back and fillet it and chamfer it, and just trying to make the best shape possible. And it just was kind of looking like a bunch of blocks which were going together in a not particularly aesthetic way. So what I did is I used the planes that I drew for those roof trim profiles, because I knew that they fit. And I actually went through and I surfaced out the entire outer shape of the headlining roof trims down to the A-pillars as well. This has honestly been a really good activity for me as well, because it's taught me a lot about surfacing and given me a lot more confidence going forward to be able to do stuff like this. And I personally think it looks a million times better as well. So I've been on with that, basically creating those outer shapes to neaten them up and getting them as perfect as I possibly can. Showing George, because George is fantastic with surfacing, is what his background's in, and he's a god at it. So showing George, getting pointers from him, implementing them pointers, and then over the last kind of day and a half, I have been going through putting in, mounting holes, splitting them down into principal chunks, ready for prototyping. Going to prototype everything, try it in the car, and hopefully that looks a million times better than what I had before. And reason why I'm telling you all this is to kind of show that yes, it may have taken a bit more time to do, but here at Retropower we just really want to have the best end products no matter what, and that also means sometimes looking at the work that you're doing yourself and going, how can I improve this, how can I make this better, how can I do this so the client is going to get the best result of the part that I'm making, and that's what I truly feel like I've done in this situation. So I'm going to leave it there for that week, guys. I'll show you some pictures of what I'm talking about, and then yeah, thank you very much, Jamie.
Thank you very much, Luke. And glaringly, obviously, I forgot, is that the fitment of the brake reservoir on this allowed us to fill and bleed the brakes, which is always a really nice sort of step forward when you actually have one functioning system on the car. So the brakes are now fully functional, filled, bled. Yeah, very exciting, and I think wiring loom is going to be the next sort of big step forward on this. I am going to end the video there. However, as per last week, we have just dropped the Dens segment on our channel. So if you look up that video now, Cars at the Den, this week Nick has done a drive in the stunning E46 M3 CSL that's down there. So check out that video now, and if you want your car looking after at the Den, please get in touch. Just drop an email to pete@retropower.co.uk and he can help get you on board. And we'll see you again next week. Right.